Hey, good afternoon. How's everybody doing? Doing well? Feels kind of different, right? Because today's a President's Day, right? And then a lot of schools are closed, but we're here. So, yeah, President's Day, right? So we're working. So I think that's the norm. I've been here for 12 years and it never, I mean, this particular holiday has never been part of the days that we get. Spring break's coming, so should be good. Oh. So any questions about the material we covered last week, actually? Uh, you have questions?
So obviously I ran into a particular problem. But I noticed that whenever I added a process with the seeds delay release, for the final report, no matter what I did to the configuration of the process, it would not show up on my tablets. Is there anything that you could potentially do whenever you're setting up a process with the C's delay and release that would prevent it from picking up the entities that you think it would?
So you are able to, so what you don't see is an output from that process block? Is that what you don't see?
Kind of. It does not meaningfully change the average cycle time. So I came up with an average cycle time that was more appropriate for only the domestic entities, and it seemed like it was not taking any of the international.
Okay. I see. So yeah, so you are not, I mean, when you look at the number of entities completed, you're seeing more than one, right?
Entities completed for which station?
For when you run your simulation model,
Mhm.
it reports the statistics and also tells you the number of entities that were.
Oh, a number in system.
Yes.
It gives me less, not more.
Yeah, in that case, I will have to look into your model
No,
individually.
I think.
Yeah, if you have a sys delay release, I don't think the problem will be the process block, because once you configure with the three operations, it shouldn't, unless, yeah, no, nothing. I mean, you by default you have at least one, right? So you have a resource operating. So I don't think that will be the problem. So I'll have to look into it, yeah.
No worries.
Any other question from previous lab? Remember that you have an assignment due on Wednesday, based on the material that we cover on Wednesday and previous week. And also you have the project. So how's the discussion in terms of the location? Or have you guys I have one student that already selected the Chick-fil-A, another student selected the Starbucks in the student center. So again, I would like to have different systems, if possible. So the rest of you, the sooner you select a system, let me know so I can tell the rest of the students that that system is selected. So make sure that you make that decision as soon as possible. And the proposal is due on the 24th. So you'll be doing those presentations next week. Okay, so make sure that you picking up on that.
This presentation, basically we need to present about the system, yes.
Yes, so there's no analysis on that presentation. It's more you telling me this is the problem that I selected, this is the problem that I'm observing. For example, you see these queues being formed during specific time of the day. You tell me what time of the day you're observing the queues. And then there, if you look at the template of the report, I think it's very specific on things that you need to list. But as an initial assessment of the system, these are the entities, these are the resources, these are the attributes that I think will be needed, variables to keep track of our performance. And then I believe there's also a portion in which you have to state, without making any analysis, what will be your suggestion in terms of improving the system. So it could be things like maybe separate customers by the type of order that they're making, or adding a resource, or maybe adding some type of iPad type of technology that you can check in by yourself. Those are things that you see in some of these restaurants facilities that can help in terms of improving the time that customers are waiting. So yeah, make sure that, again, if you have questions, I have office hours after the class today, also on Thursday. And if you can meet me during those times, you can always schedule an appointment via email. Good. So that being said, we are now going back into modeling and simulation. So we are going to be working on lab 5 today. And this lab is going to teach you how to use variables to collect some information from the system. Specifically, when your replication, when you are not using the replication number to model a day. And I think that question came last week, in which you were asking me, how do you model multiple days? Are you going to be using replications to represent a single day, or you want us to run the simulation for multiple days and then count that as a single replication and then run multiple replications with multiple days? So today we're going to be working on a model that will consider multiple days for a single replication. And then we are going to be using a variable to keep track of a statistic per day. So let's say you're running for 10 days, but you want to keep track of a daily statistic. So how do you use a variable? How do you reinitiate that variable every day? So the data that you're collecting is for a single day, even though your replication is running for multiple days. I don't know if that makes sense, but you'll see how that works in the exercise for today. And specifically, we're going to be looking at costs, right? So we are going to be keeping track of the daily cost of running some specific operation. So, so as I said, our focus today is going to be how to use variables from a different perspective. We started using the variable last time to keep track of the working process. Today, we're going to be using the variable to keep track of a cost revenue type of performance metric, which is going to be a daily cost or daily profit type of measurement that we want to keep track of. So variables are going to be our focus today. So that being said, there's not much new in terms of the slides, other than we are going to also pay attention to how we're going to be using the create block. So far, we've been using the create block to create entities that are going to be moving through our system. And those entities so far are representing something physical, right? Something that you can connect to from a manufacturing point of view or from a service system point of view, things like customers, things like parts. Today, we're going to teach you not only to use the create block for those purposes, but also how can you use the create block to create a signal for your system in order to let the system know when to collect certain statistic, right? So the create block, we're gonna have two logics today. One, representing the system that we want to model, and the second logic that is gonna be running parallel to it, that is gonna be using a create block, but to collect statistics, not to represent anything from the actual system. So that's why I'm highlighting the create block today. Another thing that we are gonna start using today is this option here that says first creation. We are gonna be stating for the second logic when we want that first creation to happen, right? So it's not gonna be at time 0 like by default, but we are gonna tell, okay, we're gonna use this logic. We want the first entity to be generated after 8 hours. So that in that case, we're gonna be keeping this time units as hours, and then we'll tell the model first creation happens after 8 hours. Okay, so that's the second thing that we are going to be doing today. Other than that, I think the rest will be similar. So this is the process, sys delay release, and as you saw, you need to add a resource name. So did you do that, right? You added a name for your resource. I don't think it's gonna, I mean, it's gonna give you an error if you don't do that.
Yeah.
So attributes, variables, decide block, and the statistics. Yeah, we are gonna be using the record block as well to collect some tallies from our daily performance. So that's another thing that we are going to do today. What else? Make sure that, yeah, other than that, I think the rest of the logic should be something that we already done. So here's the example. We have a Texas State football fans are going to buy tickets. There are currently 2 booths open with a line for each. In this example, students ignore the length of the line and join a line according to a 50-50 chance. Students that arrive to the first booth must wait 3 minutes to get their tickets, where students arriving to the second booth must wait 4 minutes. The average amount spent by fans is $80 with a standard deviation of $15. So again, very simple. As you said, as you see here, we are not stating that there's a resource. In this case, we're just stating that they're gonna go to a booth and it's gonna be a constant time that they're gonna wait, and then they're going to continue. So for the first booth, they'll wait 3 minutes. For the second booth, they'll wait 4 minutes, and then they're gonna be spending this amount of money. So that should be a very simple logic to represent. Now, in terms of the collection of statistics, assuming that the booths are open 8 hours and that students arrive approximately every 2 minutes, we want to compute the average dollars spent per customer and the average daily revenue. So we are going to be running this for 5 days. We are assuming that students are going to be buying tickets from Monday through Friday for Saturday game. So our replication length is going to be 5 days. It's going to be open for 8 hours. So 5 days, each day will be represented as 8 hours. And then we want to compute the average daily revenue, meaning that every replication will consider those 5 days and is going to compute an average based on those 5 days. Okay, so let's start our model. Okay, so let's open Arena. And so it's not showing. What's going on? Yes, that's a good question. The answer is yes. No. So once you generate that amount, you'll be assigning that value to the customer, and that's what's is going to be reported. Yes. Okay, so let's save our model. I'll be using always remember to save your model and to keep saving as you work on your system. And we are also gonna add the templates. So let's find those basic process and the advanced process. Okay, so let's start with our first create. And this create block is going to be used to represent the arrivals of the customers. So it says that they arrive every 2 minutes. So we're going to keep the expo, and we're going to change our time units to minutes, use a average value of 2, entities per arrival is 1, and the maximum number of arrivals in this case is infinite. So first creation is okay. We leave the default. So the next thing is to assign that attribute for the money that's gonna be spent by each customer. So once that entity is created, we want to go ahead and assign an attribute. So we're gonna change that. The default is variable. So we need to use an attribute, and I'll be using the name money spent. And that attribute will be based on a average amount spent by fans is 80 with standard deviation of 15. So even though if it is not stated, we typically the distribution that we typically connect with those two parameters, average and standard deviation, is the normal distribution. So we're gonna use the normal with a mean of 80 and a standard deviation of 15. So that's the distribution. So I'm gonna build an expression here. I'm gonna go to random normal. It's 80 and 15, right? So it's a normal 80 and 15. So what we're doing here is just assigning that attribute because we're going to use that attribute to compute the amount of money that's been spent. Second thing, or the next part of this model, is to split the entities, and we are going to split them based on a probability 50-50, right? So I'm going to use a decide block. And the default is what we need, which is two-way by chance. So 50% through, they're going to go through one of the branches, and then the other 50% will go through the false. Then, as I mentioned, the model is not stating, or the description is not stating that there's a resource. I guess it would not hurt to model this as a resource. So we can go either way. We can define this as just a delay that the entity will be hold by this block 3 minutes and then move forward. Or we can represent it as a independent resource. At the end, the difference is not gonna be, we can try how much of difference we'll see, but I don't want you to get confused. I'm gonna be using the process, and instead of just stating this as a delay, I'll call this booth one. Got two booths. And then this is gonna be constant in minutes with a value of 3. It's 4. So the first one is 4 minutes, 3 minutes, right? 3. And then we'll have a second process. Constant in minutes, and this one is 4. So if you think about it, we'll have customers arriving about every 2 minutes. Processing times are 3 and 4. We're splitting the arrivals, so we should have enough capacity to cover the customers. With one of them processing at 3 minutes, the other one processing at 4 minutes. So I expect to see some queues, but not very long queues. So they're separated, connected to the 50/50. And now is where we start collecting the information about the statistics that we want to collect. So first one is the average dollar spent per customer. So for that, we can just use a record. And we are just collecting the information from that attribute. So if we come here, we add, this is gonna be an expression. The value will be money spent. And the tally name will be a good tally. Dollar spent customer. So we call the attribute here. So what we should expect to see, since we're using a normal distribution here, that value at the end, when we look at the average of the money that's been spent, it should be close to that average that we stated for the attribute.
So when you select the title expression, it automatically detects the normal distribution that we.
When you select that's a good question. So remember, so far when we define this record, we have used a count to count units. We also use the time interval for computing the cycle time. In this case, we are collecting something else, which is just a single value. And the value can come from different ways, right? Even for the cycle time, you can use an expression, right? You just, instead of, because when you do time interval, it's just gonna, it's avoid you to have to define the T now minus, right? It is built already in it, but you can do it through an expression and put the T now minus the attribute. It will do the same thing. But in this case, since we are not computing anything, we are just collecting information straight from the attribute. We just put the name of the attribute. If you needed to do something else with that value, like you're charging, let's say, a convenience fee at the end of the transaction, you can also build that into this. You can just say money spent plus whatever the convenience, and it will collect that information. But to answer your question, yes, expression is there. You can use it for most of the information that you will be collecting, except from the count. But since the cycle time is something that we collect a lot, the system or the software already built something in to avoid, or to make it simple, I guess, without having you to remember that you have to use the T now minus the attribute. Yes, sir.
Maintain the right format, money spent and the way right.
Money spent, yes, it has to be exactly the name that you're using for the attribute. Yes. Yes, so it will look for that as an attribute. And if it's not written with in the same way, it will give you an error. Yes.
So you have a value and you have a tally name, and we're just moving away from finishing to define all the tallies. So whenever you're writing that tally name right there, dollar spent customer, are you actually defining a new tally? Because I've never defined any tally name.
This name right here,
Yes,
yes,
sir.
it is it is naming the bucket where you're going to be collecting this information. Yes.
But once you create the statistic, you don't have to go back and define it in like a tally.
Once you define this name,
Yes,
yeah, that container, once you put that name here, is gonna be creating that new container
okay,
there.
so there's no double.
You don't have to define it beforehand. So I think, yeah, and that's a good question because with the previous set of blocks, we needed to go and build define everything beforehand. In this new set of blocks, you don't have to. You can just build that information straight from here. Yeah, so that's a good question. Once you do that, you can close this. Okay, so that's gonna be that container that we just created, that tally. It's gonna be putting all those values inside that container. At the end of the replication, it will look for that container and will compute the average and the halfway and the maximum and the minimum using the information that is inside that container. And that's what we want for that first statistic. Average dollar spent, right? Because we want to know per customer, what's the amount of money on average that is being spent. So that's simple. So now we want to transition to the next one, which is the average daily revenue. Right, so we're gonna start by setting up this for a single day. So if I want to collect the revenue for the day, and I'm running just this for a single day, what I have to do is to go and add a variable that is gonna be adding all these values per customer. And at the end of the simulation, that variable will have a value, and that's what's gonna be reported by the system, the final value at the end of the simulation run. So let's start with that. I'm going to add a sign. Okay, so in this assign block, I'm going to define a variable that is going to tell me the revenue. So I'm going to name this revenue. Yes, it's gonna be revenue plus money spent. So all variables are initiated with a value of 0, right? So at the beginning of the simulation, that revenue variable is gonna be 0. And as you start running the simulation, it's gonna keep adding all this money spent per customer. So as you can see, that attribute is being used in multiple places here. After defining that, you have the record and now for the revenue. Okay, so let's see. And again, we will start with this first. See how that works. Let's put the dispose and save it and check the model. Let me know if you have any problems. Any errors, problems? Nope, good. So let's set up the simulation. Let's go here, do setup. Let's skip the number of replications equal to 1 for now. We're gonna run this for 8 hours. Hours per day is gonna be 8. And the base time units is minutes. I'm going to click apply. Then I'm gonna go here, call this example 5. And I'm going to uncheck all this. I just want to see the values that I coded for this experimentation. And then select the summary report. Click apply. Apply again. And then save it. And after that, you can click the play button. You see the animation. It will take a little longer for you to see the results. So once that's done, we got only the dollar spent. We didn't get the variable reported, so we need to do something else. So as I said, if you look at that average, it's almost 80, right? So that's what we are expecting because we are using a normal with 80 as a mean. But you see the values, the maximum and the minimum, you have some variability there. Even though, because you're seeing that bell shape, yes.
Can we go back to the the project setup? I'm sorry.
Yes, no problem. Let's go back to the setup.
Where was the part where we set it up for the replication parameter for multiple days?
No, we didn't. We kept
Oh.
this as a single replication with a replication length of 8 hours. So far we're gonna do that next. Okay, so far, want to make sure that these variables are working. So we didn't get the report for the variable. So we need to include that as part of our statistics. So go to the advanced process. Here we have the statistic. We're gonna be adding 2 because we know we're gonna need both once we start running multiple replications. So the first one is going to be for this tally. So the tally name is this one. So I'm gonna copy this dollar spent customer. And I'm going to go here and define an output with the TAVG name of the tally. And I'm going to name this AVG dollar spent per customer. That's gonna be for the tally. We'll try something here. That's you. I just put the name of the tally of the variable here. See if I can get that. So this is gonna be revenue. And I'm going to call these daily. See if that works. Save it. You know, I think I mentioned this before. You can click on this batch run, no animation, and it will run faster. Okay. So by reporting the daily revenue as an output, we get that final value for that variable. You see that average dollar spent per customer is gonna be the same for the identifier or for the tally variable, as well as for the output. So here we have our output, the tally variables. This should be the same. And now we got the revenue. Okay, so the next part is where it gets, I think the novelty for today is how do we handle that daily revenue for multiple days? Yes.
35. The deviation is only 15, so it would be 79 minus 15.
Well, the standard deviation is 50.
Yeah.
Right, but if you know how the normal distribution look like, you got the 80 here, right? And then that'll be the top of the bell. But this distribution will continue. It never touches the actual zero basis, right? So you can, even though the standard deviation is 15, you can still get values that are on those sides. They're very unlikely, but they can happen. It's good questions. Okay, so let's proceed with the daily component. Okay, so now if you, for example, I want to show you what would happen if you change this to 8 days or 5 days. Let's put this 5 days, right? 5 days. You run this. Obviously, you'll see that daily revenue will multiply times 5, right? And that's what you're gonna see 5 days. That average dollar spent doesn't change much, but this is basically multiplying 15 something times 5, right? So that's not the daily revenue, that is the total revenue for the 5 days, but that's not what we want. Okay, so how do we compute that daily revenue? That's the question. Okay, so as I mentioned at the beginning of the lecture, we're gonna be creating a separate logic that is gonna be parallel to this one. And the purpose of that logic is just collecting information from our system. Okay, so we are gonna go here and we are gonna call or bring a create block. That create block is gonna be generating an entity, and that entity is going to basically create a flag into the model to go reset our variable. Okay, so our create block will be generating an entity every 8 hours. And I want that to be constant. And I want my first creation to happen after 8 hours. what I want this create block to do is to generate that entity at the end of the day. So that's what the logic should do. At the end of the 8 hours, we'll generate an entity. This entity is not representing anything in the system. Again, this is just a logic to collect data. So once that's happening, I want to go here and get one record block. And after 8 hours, I want this to create a tally. So again, I'm going to be using this expression. And that tally is going to call that variable revenue. And it's going to put that value in this container. So at the end of the first day, I'm going to go grab that value and I'm going to put it in that container. After 8 hours, I'm going to generate another entity and it's going to go and it's going to say to the tally, go get that value again and put it in the bucket. After 8 hours, again, go get that value, put it in the bucket. Okay, so every 8 hours at the end of the simulation, if I'm running this for 5 days, I'm going to have 5 values in this container. Yes, so we have to do one more thing. Yes. So I need to go here and find that variable. After I get the value that I need for the day, I'm going to say, I got the information, go restart, because you're going to start a new day. And then the simulation will run for 8 hours, get the value, do the same thing. After 8 hours, do the same thing. And you do that 5 times. Yes.
So whenever we're putting down the second create block, we're still gonna be creating entity one, which is the same type of container that we're using to track the people or the product.
These are going to be 2 different sets of
Right.
entities.
They're
Yeah.
interacting
No.
with each other.
No.
Is there any meaning to changing the type of entity for like reporting purposes, or do you think that?
At this point, it's not gonna make any difference. Okay. When we get into, let's say, the animation, let's say you have different part types, you can start adding attributes associated with colors or associated with shape, and those will be represented within the simulation.
But you're referring only if they're sharing the same flowchart.
Yes.
Okay.
Yes. Yeah, these two, they're separate. They are created and disposed separately, so they never interact.
worry.
Yeah, they don't have to worry about that. Okay. Okay. So as I said, once those entities have achieved what we wanted them to do, we're just disposing them. They're destroyed. Nothing happens. Okay. So now I have that tally, recording, assigning 0, and disposing. Okay, so I need to do one more thing. See if this is gonna copy this value here for my daily revenue, which is the name of the tally. And I'm going to go to the statistics. And I'm going to create another output. But I want the average of those 5 values that I collected inside this tally. So I do TAVG for that tally. And this is gonna be AVG daily revenue. So I'm gonna keep this here, but understand that the value that is gonna be reported is just for the 5th day. That last value that is collected by the tally, because this output is just looking at the variable and getting the final value at the end of the simulation. So this should look like 15,000 something. But it's the value for the 5th day. And then this average should be also around 15,000 something. We'll see. So save it, run it.
Would your final revenue be zero because we're initializing?
Yes. Forgot about that 5th entity, right? Yes. So at the end of the simulation, it will reinitiate. That's why you're seeing the zero. So get 18,000 here for the average daily revenue. Because this is single replication, we need to run this for multiple replications. Let's see how that goes. So let's stop this. Go setup. Let's do it for 10.
That multiplication to 5 days.
Yes. So yes, you run more replications. Remember that discussion that we had, more entities, more observations. That minimum and maximum is getting pretty close to the center. Daily revenue, you have 18,953, the minimum and the maximum between those two. This is zero, because we are initiating that after. Let's see how that looks like. Let's try to make sure that what will happen if we don't reinitiate that value. So I'm gonna put in the create block maximum 4 and see what happens. So it's reporting that final value. And it's averaging that final day. See here, the variability is a little higher because you don't have as many observations. It's still close. But this is the value that we were looking at, right? The value across replications. I don't know if that's confusing you more or not, but remember, this is just the variable. This is not, there's no tallies here. This is just the last value that is reported by the simulation for the variable. This is with the tally. You're looking at the average across days per day. And then we are averaging all replications. And then the average spent by customer is right here. Yes, sir.
Never mind.
Yeah.
I was kind of confused, but yeah, the total profit versus the average total profit. Is there a way of creating a different container and comparing the total profits throughout like the 5 days?
We will have to define a different variable. One that is not,
Being
we
used.
don't reinitiate it, yeah.
Yes, okay.
It's,
So in the output summary average daily revenue, we can simply say that it is the average of 50 applications. 5 multiplied by 10.
no. That's a good question. The experiments are given by the total number of replications, but each experiment duration is that replication length. So in this case, your experimental, the length of the experiment is 5 days. Right, so each experiment is gonna be 5 days long. And you're running each experiment 10 times.
Yeah.
10 times. So when I say the replication, when you build or you run a replication, you're setting up a random number generator that is based on a specific seed. It is using that same seed for the entire experiment. And that's what's defining your replication. You're using a unique random seed to generate your inputs. Okay, so that experiment is based on that random seed. Every time you change the random seed, you're basically providing new conditions to your system. And that's what makes a different experiment. The length is just based on your system, right? What is the interest or what type of decision you're making, right? That's how you're gonna be deciding the length. But the different type of input trajectories that you're going to present your model, that's an experiment. So if you want your system to be very robust, you want to test it against different input trajectories to see how it's going to be reacting to different conditions, different arrival patterns. The more experiments you run, the better you will understand how robust the system is. If you just run it for a single replication, that input trajectory will be not enough to tell you how good or bad your system is, because you could generate another random set of input parameters and it might not perform as well, right? So that's why again, the replication length is going to be based on the decision maker, based on the system that you're working on. But the number of experiments is to evaluate how robust your system is, and the larger the number of experiments, the better assessment you will get from your system. Yeah, that makes sense.
Yeah, could you suggest to me textbook for this simulation, because
Textbook for simulation?
Yeah.
Yes. So there's that's a good question. So there's in the syllabus, I have references that are the ones that I'm using for preparing the slides. There's a book that is specifically for simulation with Arena. That's the one that I recommend. And you can find it online. It is available online for you guys in the library. So if you want to go deeper in terms of the simulation, there's I think 1 or 2 references in the syllabus that you can use.
You mentioned replications as a source of estimating different trajectories.
Input trajectories, yes. And what I mean by that is, for example, the arrival patterns. When are the entities arriving into your system?
Yeah.
Yes.
Are we going to, because I'm assuming that you'd want to take a look at particular perspectives at these input trajectories. Is there a way, as of right now, we're just randomly doing replications? Is there a way of purposely
Control those input trajectories? That's a good question. The answer is yes. You can. When I said yes, there's a way for you to control the random seed that you use for the experiments. Now, if you're talking about, because that's what that's going to do, is just providing a new seed to the probability distributions that you already validated for your model. Like when you do the project, you say, okay, my arrival pattern follows this distribution. That distribution is not going to change. The only thing that is going to change is the input that you're providing as a seed.
Okay.
So your arrival patterns will be different, but they are still based on an exponential distribution, right? If you are studying a system that the arrival pattern will be constant in that sense, not constant, but similar in a way that you know it's not going to deviate a lot. So most of the time it's going to be following the exponential, then switching the random seed and getting different input trajectories based on that. I mean, it's what you want to do in that case.
Right.
But if you have a system in which you're observing different arrival patterns on different days, we're going to teach you how to manage those also in class. There's certain tools that we can use for those purposes. But it might be the case in which different days, different products, different seasons, you have different arrival patterns. And that might need for you to collect a different set of data that might tell you this distribution for this season is different.
Yeah.
So in those cases, you might need to run separate experiments per season. These are following these distributions. These season follows this other distribution. At the end, you're not just changing the input seed for your probability distribution, for your random seed, but you're also changing the probability distribution that is representing the process. Yeah, so again, depends on the system, right? There are systems that are not going to change much because they're stable in a sense. You get orders that are similar. Those products are very well established, so the processes are not going to change. But then when you start bringing seasonality and you start bringing changes in customer demands or changes in people asking certain things on specific products and so on, packaging differently and so on, then you might need to separate the environments based on those characteristics. Any other question? Yeah, simulation is fun. I don't think, I mean, based on my experience, there are companies that see the value on simulation and they have teams working on simulation models, like groups. They're not very big, like a group of 4 or 5 people assigned to build simulation. But understand that to build a good simulation model, you need time to collect the data that you need to do the assessment, to build the model. So there will be other companies that will hire consultants to do that type of work. Or in reality, most of the time, decisions are based, you don't have the time to build something like this. I know pretty sure that Samsung, for instance, which I have students working there, that they are assigned to simulation teams and they do a lot of simulation. Sometimes they use Arena, sometimes they use Simio, sometimes they use FlexSim, which are different software packages. But based on what the feedback that they're getting, I'm getting from them is, if you learn one software package, you can take that knowledge and bring it to these. I mean, you just need to learn the interface, but the concepts are mostly the same. Which is my experience as well with, at least with Simio and Arena and Analogic. They're different interfaces, but the actual essence is the same. Any other question? Yes.
Is it prevalent though to do some of these simulations just like in plain Python? Because I'm assuming this is like happening either in like C.
Yes. So that's a good question. So when you have these software packages, these are targeting people that might not be very strong in coding, right? So these kind of help you have the visual interface. But there's, yeah, all these languages will have some type of coding classes that you can use for simulation. I know Python have some agent-based. I haven't experience with, I don't have experience with discrete event simulation using Python, but I know they have classes for and packages for agent-based simulation. I myself, I did simulation as part of my dissertation, and it was all coded in Java. So I was not using any software package. Yeah. So yeah, when you get to yeah, that's, I mean, dissertation type of work, if you typically don't rely on software packages, you have to build your own code. But yes, as there's open source, obviously they will require a level of coding that is a little bit more elevated, yeah, to use it.
So, thank you, question, that's
Mhm.
gonna be my last question, moving from the old blocks to the new blocks, it does get a little bit confusing where we're keeping all of the knowledge of all the things that we're
Yes.
describing. Is there a way, whenever I set up the project, to extract what it translates to in just like a big block of code? Because once, like, you can compare the
Mhm.
big block of, for me, it would be a tiny bit easier than like looking if it's in the statistic file or in the.
Yes. So to answer your question, at least for the proposal and for the second report, I'm not asking anything about the code, right? You will get into the code for the last report, which is towards the end of the semester. So I'm aware of that constraint because you're just getting started with the simulation. But that's good feedback because my vision was to try to give you as many tools as possible but we have only one semester, and I don't want you to get confused. And then at the end, instead of giving you more information and knowledge, you end up not knowing to work with any of them. So that's good feedback. I can tell you that we are not transitioning to any other set of blocks and set up blocks in Arena until you feel comfortable with this one. Okay, so if I see that you continue to struggle, I might keep just this set of blocks and continue using them until the end of the semester. But if I feel like you're comfortable, maybe I can add some, because there's a new set, and as I said, this set, I think the only thing that they're doing is just changing colors. It's not, for me, it's more confusing than the group of blocks that you are using. They're not different, they're just separated differently in terms of colors and combining some things that you know how to do already. Yeah, but thank you for the feedback. I'm not expecting code in this first part. Second part of the project is just data analysis, so there's no coding at that level. By the time you get to implement your model, you should have enough practice with this set of blocks that you should be okay. Now for the exam, if you're thinking about the exam, if you feel comfortable with the first group of blocks and elements, and that's what you want to use for the exam, that's fine. For me, that's fine. You don't, I mean, I want you to get familiar with this set of blocks. But in the exam, if you feel more comfortable with the previous one, then you can use those. Any other questions? Good. So I'll be in the office. I recorded this for today. So you'll have access to the video. I forgot to upload the video for the previous one. Nobody told me anything. Again, you guys are so quiet. If you feel that I forget something, send me an email. Yeah, so I had the video, I uploaded to YouTube, but I forgot to update the modules. So yeah, I noticed this morning, I said, well, I updated today. So I don't know if that makes any difference or not, but the video is there now. Okay, so if there's no other question, I will stop. Yes, go ahead.
Do we need to model the